In this lesson, you will learn how to find the sum and difference of matrices, as well as the products of a scalar and a matrix. So let's begin with finding the sum of a matrix. So when you find the sum, what you do is you add the corresponding elements together. So for example, we see here these two matrices, and to add them, we need to add the red numbers together and the white numbers together. So when you add the 2 and the 3, we get 5, and then 0 and negative 4 give me negative 4. Those are the corresponding elements added together. Here's another example where now we have a different size of matrix, and same concept. It's color coordinated here to make it easy to tell what we're adding. So we're adding the reds together, the whites together, the greens, and the purples. So negative 4 plus 6 would be a 2, 0 plus 3 is 3, 2 plus negative 5 is negative 3, and negative 1 plus a negative 3 would give you a negative 4. So when you add them together, you just add the corresponding parts together. Now when you add them, the dimensions of the matrix does not change when you add together. And we call that the closure property. We started with a 2 by 2 matrix, we added a 2 by 2 matrix, and we ended up with a 2 by 2 matrix. Also, subtraction works the same way, where you subtract the corresponding parts. So negative 2 minus 4 would give you a negative 6, 3 minus 5 would be negative 2, 4 minus a negative 3 would be 7, and 1 minus 0 would be 0, or 1, sorry. So a little side note, in order for this to work, we need the dimensions of both the matrices to be the same. So for example, you cannot add these together because we have two different sizes of matrices. One is a 2 by 2 matrix, the other is a 2 by 3 matrix. So these cannot be added together. Now another property of matrix addition is that it is commutative, meaning that the order does not matter in which I add the matrices together. So for example, we see on the left side, we take 1, 2, 3, 4, this matrix, then add all the negative ones together. That's the same thing as adding the negative ones first with the positive ones second. The order in which I add does not make a difference. Another concept with matrix addition is what we call the identity matrix. Now when you hear the word identity, usually you think of what something looks like. And with an identity matrix, what it is a matrix that we can add that does not change the identity or the way the original matrix looks. So for example, if you have the matrix negative 1, negative 2, negative 3, negative 4, notice if I add this 0 matrix right here, that it does not change the identity of the original matrix. So this 0 matrix is what we call the identity matrix for addition. So the identity property basically just says that this matrix exists. Now we have what's also called the additive inverse. The additive inverse is what we have to add to a matrix to get back out the 0 matrix. So for example, if we have the matrix 1, negative 5, negative 3, and 2, then the additive inverse is what we add to get back out the 0 matrix. So what do you add to the 1 to get back out a 0? Well, if I add a negative 1, I'm going to get 1 plus negative 1, which will give me a 0. With the negative 5, if I take the opposite of negative 5, I get a 5, and I add those together, that gives me 0. For the negative 3, it's got to be a 3 that adds to get 0, and the 2 adds with the negative 2 to get 0. So the additive inverse would be this matrix here in green. And basically all we're doing for the additive inverse is we change the signs of the original numbers. So positive 1 becomes a negative 1, the negative 5 a positive 5, and etc. So this matrix would be your additive inverse. And this whole concept is what we call the inverse property. And the inverse property basically just says that the additive inverse exists. Or in more specific terms, if a matrix and the additive inverse are added together, the answer is the 0 matrix. Now, if you were asked to find what is the additive inverse of this matrix, what I do is I change the sign of every number. So the -1 becomes a +1, the 0 just stays a 0, 3 becomes -3, 5 becomes -5, -6 becomes +6, and +7 becomes a -7. Same for this next example. The +1 would become a -1, -3 becomes a +3, 0 stays a 0, and 2 becomes a -2. So to recap what we just discussed, we have different properties of matrix addition, and the first one is the closure property, which says that the dimensions of the matrix will not change when you add or subtract with another matrix. Second, we have the commutative property, where it says if we have two matrices added together, such as A plus B, it does not matter if I add A then B or B and then A. In other words, it does not matter the order in which I add. The order does not make a difference. Next, we have the associative property, which we have not discussed in the context of matrices, but you've learned before in your study of math, where the term associate means things that are together. And in this case, these are things that are grouped together. And in the context of matrix addition, what the associative property says is if I have three matrices you're adding together, it doesn't matter if I add the first two first and then add the third one after, or if I add the second two first and then add the first one in after the fact. Or in other words, we can move the parentheses around and it does not make a difference. A fourth property that we have is called the identity property. And the identity property says that I can add the 0 matrix without changing the identity. And the inverse property says that if I add the inverse, the additive inverse, I'm going to get back out the 0 matrix. So now we have dealt with matrix addition. Now we're going to deal with scalar multiplication. So in matrix algebra, a real number is called a scalar. So 3 times matrix A can be written as 3A, and 3 would be the scalar. So for example, if here is matrix A, where you have 2, 1, -3, 0, then 3A would be 3 times everything in the matrix. So 3 times 2 is 6, 3 times 1 is 3, 3 times -3 is -9, and 3 times 0 is 0. And that is all there is to scalar multiplication. You just multiply everything in the matrix by the scalar. Now a few properties with scalar multiplication as well. First is the closure property, which is the same for matrix addition, and that says that the dimensions of the matrix before and after multiplication do not change. The second property is the commutative property, which says it does not matter the order in which I multiply. If P is my constant, A is my matrix, I can take P times A or A times P. So the order does not matter. Now to illustrate that, here I have matrix A, and here I'm going to multiply 3 times matrix A. Now it does not matter if I take 3 times 2, or I do the 2 times 3. So if I do 3 times 2, I get 6, 3 times 1, I get 3, 3 times -3 is -9, and 3 times 0 is 0. Or I can do A times 3, where I multiply by 3 after. So I do 2 times 3, 1 times 3, -3 times 3, and 0 times 3 to get this same resulting matrix. The next property is called the associative property. Same thing as with matrix addition, where it does not matter how I group things together. So if I have two scalars, P and Q, and I multiply that by the matrix A, it doesn't matter if I multiply Q by A and then by P, or multiply the two scalars P and Q and then multiply by A after. I can group together the different values differently. So I can move the parentheses around as needed. So for example, here we have a equals 2, 1, negative 3, 0. If I have two scalars out front, so 3 times 4 times a, well, according to the associative property, I can multiply 3 times 4 first to get 12, then multiply 12 by the matrix to get 24, 12, negative 36, and 0. Or I can group together the 4 and the a, multiply those first to get 4 times 2, which gives me 8, 4 times 1 is 4, 4 times negative 3 is negative 12, and 4 times 0 is 0. And then multiply by the 3 to get 24, 12, negative 36, and 0. Notice, both ways I get the same solution. And that is called the associative property. Next we have the distributive property, which is the same as what you've learned before in algebra, where if you have a scalar times two matrices added together, I can distribute the scalar, multiply it by the first matrix, and then multiply by the second matrix. So I have p times a plus p times b. So for example, if I have 3 times these two matrices added together, what I can do is I can add them together and then multiply, or I can distribute. So here I add first the 2 and the negative 2 to give me 0, 1 and the 4 give me 5, negative 3 and negative 2 give me negative 5, and then 0 and 6 would add together to give me 6. And then I multiply by 3 to get 0, 15, negative 15, and 18. And that is the same thing as multiplying the 3 by the first matrix and then 3 by the second matrix, and then add them together. So 3 times the first matrix, I get 6, 3, negative 9, 0. Second matrix, I get negative 6, 12, negative 6, and 18. And then add together, and notice I'll get the same resulting matrix. So the distributive properties also holds true with scalar multiplication. And the fifth property is called the identity property for multiplication. And remember, the identity property says that we can perform an operation without changing the identity of the original matrix. So for multiplication, when you multiply by a scalar, what do you multiply by so that the original matrix does not change? Well, the answer is going to be you multiply by 1. 1 times anything does not change the original number or matrix that you started with. So the identity property says 1 times any matrix will equal the original matrix. And now to finish off this lesson, we're going to deal with what we call matrix equations, which is an equation where the variable is actually an entire matrix. So for example, we have this equation where you have 2x plus 2 times this matrix equals 8 times this matrix. Now to solve this, I need to get x by itself. And to do that, one of the first things I like to do is simplify the 2 times this matrix and the 8 times this matrix. So let's multiply by the scalar first. So 2 times the first matrix, I get 2, negative 4, 0, and 6. 8 times 1/2 gives me 4, 8 times 0 is 0, and then 8 times negative 1 is negative 8, and 8 times 1/4 would give me 2. So to solve for x, just like any equation, I need to get rid of the 2 and then get rid of this equation, or this matrix as well. So to get rid of this matrix, I need to subtract this matrix over to the other side. So I'm going to subtract this 2, 0, negative 4, and 6, and so that this will cancel. And same thing over here, subtract the 2, 0, negative 4, and 6. So now I would have 2x equals, and then these two matrices subtracted from each other. So looking at these two matrices subtracted, I get 4 minus 2, which gives me 2. 0 minus negative 4 is 4. Negative 8 minus 0 is negative 8. And then 2 minus 6 is negative 4. And then to solve for x, I now need to get rid of the 2. So to get rid of the 2, I divide everything by 2. And when I divide by 2, that's the same thing as multiplying by 1/2. So you can think of it as dividing by 2 or multiplying by 1/2. Either way, when I take 1/2 of each of these numbers, I would get 1, 2, negative 4, and negative 2. So my answer, my matrix x, would equal 1, 2, -4, -2. And that concludes our lesson for today. We will see you next time.